Okay, picture this. You're at the doctor's office, right? Stepping on that old school scale, the one with the sliding weights.
Right. I know what you mean.
And the assistant is adjusting them back and forth, zeroing in on your weight.
It's always a process.
It is. Believe it or not, that's actually a surprisingly accurate analogy for how one type of analog to digital converter works.
Oh, really?
Yeah, an ADC. We're talking about the things that take the real-world stuff, sound, temperature, even your weight, and translate it into, the digital language of ones and zeros, the stuff that your phone, your computer, basically everything around you understands.
It's the bridge, then, between that whole symphony of continuous signals, the physical world, and the digital domain, which can only handle those discrete values.
Exactly.
We'd be lost without them. It'd be a much quieter world, that's for sure, visually, too.
Exactly. So today, we're going to take a deep dive into 4 main types of these digital translators: SAR, Flash, sub-ranging Flash, and Sigma Delta ADCs.
Okay.
We'll uncover how they work, their strengths, their weaknesses, and, why you should actually care.
And I bet you'd be surprised how much they impact your day-to-day life without you even realizing.
Absolutely. So let's start with that scale analogy.
Okay.
Because it perfectly illustrates this concept of a successive approximation register ADC,
Right.
better known as a SAR ADC.
Right.
So imagine the scale's sliding weights as the ADC, making a series of guesses to figure out your weight.
Okay, I'm with you.
Right.
Yeah.
So it's like an auction, really. The SAR ADC starts with a guess in the middle of the possible range, right?
Yeah.
So let's say 150 pounds on a scale that goes up to 300.
Compares that guess to the actual voltage coming from the sensor. In this case, the scale's pressure pad, and determines if it's higher or lower.
So if the voltage from the scale says you weigh more than 150 pounds, the ADC knows to adjust its guess upwards.
Precisely.
Yeah.
Then it makes another guess, say 225, compares again, and keeps narrowing it down this way, this back and forth, until it lands on your exact weight, or at least a very close approximation.
Okay, that makes sense. But like that old school scale, it seems like it might take a while.
You've hit upon a key trade-off with SAR ADCs. They're known for their accuracy, but that precision, well, it comes at the cost of speed. They're slower because of that step-by-step process.
That makes sense. So for applications where speed is less of a concern, like maybe measuring temperature or something,
Sure.
a SAR ADC would be a good fit.
You got it. It's all about choosing the right tool for the job, right?
Yeah.
But what if you need lightning-fast conversion, like when you're capturing high-speed data or dealing with real-time audio? That's where things get really interesting.
Okay, so SAR ADCs are methodical,
Mm-hmm.
like a careful detective, right?
Right.
Piecing together clues.
Yeah.
But what about situations where you need instant answers?
Mm-hmm.
Like when you're trying to capture a super fast event or maybe process real-time audio.
Yeah, that's where flash ADCs come in.
Okay.
Instead of that single scale making these careful guesses, imagine a whole room full of scales,
Okay.
each one preset to a specific weight. You step on and boom, all the scales react at the same time, giving you an instant readout.
No, that's a pretty vivid image. So instead of guessing, a flash ADC is comparing the input voltage to a whole bunch of reference levels at the same time.
You got it.
Yeah.
It's like having this massive parallel processing system.
Wow.
Each comparator, or a mini-scale in our analogy, checks if the input voltage is above or below its preset level. And this parallel comparison, that's what allows flash ADCs to be so fast,
Wow.
converting analog to digital almost instantaneously.
That speed must be super crucial for things like high-speed internet or capturing those crazy detailed slow motion videos. Right?
Absolutely. Think about capturing like high-definition video at 120 frames per second.
Wow.
Each frame requires millions of pixels to be captured and converted from light intensity to digital values. And it all has to happen in a fraction of a second.
That's mind-boggling.
Yeah.
But all those comparators, all those mini scales, that must make flash ADCs really complex to build.
They do. They do indeed. And that complexity, well, it comes at a price. Flash ADCs are significantly more expensive than SAR ADCs, especially when you need higher resolution.
Yeah.
Remember, higher resolution means more possible digital values, which translates to even more comparators.
Right.
Right.
So it's trade-off again. Speed
Yeah.
for cost and complexity. There's always a catch, isn't there?
It seems that way.
But the whole idea of parallel processing is fascinating. Do any other ADC types use that kind of approach?
They do. It's such a clever solution that engineers have found ways to combine it with other techniques to, kind of get the best of both worlds. Like, for example, there's something called a sub-ranging flash ADC, which is like a 2-stage rocket for analog to digital conversion.
A two-stage rocket?
Yeah.
Okay, now I'm really intrigued. Tell me more.
So imagine instead of searching a huge field, right, for something tiny, you split everyone into groups, to cover more ground.
Right.
That's the basic idea behind sub-ranging flash ADCs.
Okay, so it's like dividing and conquering
Exactly.
to speed things up.
The first stage makes a quick but less precise measurement just to narrow down the possibilities.
Right.
And then a second flash ADC swoops in, but it only has to analyze that smaller range.
Okay.
This means fewer comparators, which makes it faster, less complex than a full-blown flash ADC.
Clever. So sub-ranging flash ADCs are kind of like a compromise then,
Yeah, you could say that.
between the meticulous SAR and the Speed Demon flash ADC.
Precisely. They're a great option when you need good speed and accuracy, like in digital audio recording or some medical imaging applications.
Right.
But what if we need to really crank up the accuracy
Okay.
even further,
Yeah.
even if it takes a little bit longer? That's where Sigma Delta ADCs really shine.
Oh, yeah. We can't forget about Sigma Delta.
Right.
They're the ones that are all about precision.
Think of a scientist, right, meticulously taking multiple measurements
Okay.
and averaging them to eliminate any errors. That's the essence of a Sigma Delta ADC.
Okay.
It samples the analog signal way more often than you think is necessary, and then averages all those samples to cancel out noise and get a super accurate representation.
So it's like when you're trying to have a conversation in a loud, crowded place.
Yeah.
And you have to kind of filter out all the background noise to focus on the words.
That's a great analogy. And just like our brains, Sigma Delta ADCs, they excel at suppressing noise. This makes them perfect for applications where every tiny detail matters, like high-fidelity audio, precise scientific instruments,
Right.
or capturing those, incredibly detailed images we see in medical imaging.
It's amazing how these different approaches all have their own strengths. So we've got SAR for accuracy, flash for speed, sub-ranging flash for a bit of both, and Sigma Delta for when you need to be super precise.
Yeah.
It makes you wonder, is there a way to combine all of these advantages?
That's the holy grail, isn't it?
Right.
And, engineers are working on it. There's this new type of ADC. It's called a flex ADC.
Okay.
Think of it like a Swiss Army knife of ADCs.
Uh-huh.
It can adapt its resolution, speed, and even its power consumption all on the fly to match the specific requirements of whatever signal it's converting.
Wow, a real chameleon of the ADC world. What's next? AI-powered ADCs that can, predict the future of analog signals.
Well, I wouldn't rule anything out. The world of ADCs is constantly evolving as technology progresses.
Yeah.
Who knows what brilliant solutions engineers will come up with next?
That's the beauty of technology, I guess. Always something new and amazing just around the corner.
Yeah.
But hey, even without predicting the future, it's pretty mind-blowing to realize that these little microchips are working tirelessly behind the scenes. Converting the real world into the digital experiences we rely on every single day.
It really is. The next time you listen to your favorite song, snap a picture, or even just check the weather app on your phone,
Yeah.
Remember those unsung heroes, the ADCs, translating the language of the universe into something that we can all understand?
Well said. And on that note, we'll wrap up our deep dive into the world of analog to digital converters. Hopefully you've gained a newfound appreciation for these hidden heroes of the digital age. Until next time.